Hey class, I told you I would do this problem and post it this evening, the night before the test. So the problem was the football team's Gatorade is leaking at a rate of 1.5 ounces per second, and I would like this converted into gallons per week. So you can see where we're starting, right? We're starting at ounces per second, and we've got 1.5 of those. So I'll start with 1.5 ounces, OZ, per one, right? It's just, oh no, per 1 second, per second. And at the end, I want this to be converted to gallons per week. So gallons per week is the target that I'm looking for. So I'm going to go ahead and take care of the time first. I'm going to get my seconds converted up into a week. So um, time conversion, I think you guys know most of the giant ones that we'd use for that. And I will supply some conversion giant ones that are appropriate for any problem that you see on the test, with the exception of time giant ones. So let's go through the time conversion here. So I'm starting with the second in my denominator, so I'm going to put seconds in the numerator, and I know how to get those into minutes. And in fact, I know that 60 seconds is 1 minute. Now I'm going to get rid of my minutes, so I'm going to put minutes in my numerator, and I'm going to go to hours. I know that 60 minutes is equivalent to 1 hour, and I'm going to go get rid of my hours, and I'm going to go to the units of days, and I know that 24 of the hours is equivalent to 1 day. And then for the final one, I got to jump to weeks. So this last one is I've got 7 days is equivalent to 1 week. So the big idea here is that all of these units, right? This is the number 1, 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 right? 60 seconds is equivalent to a minute. So I've got the same amount of time divided by the same thing, so it equals 1. And that's true for all of these ones. 24 hours is indeed a day, 7 days is indeed a week. Now at this point, what I do is we can form giant ones with our units. So if you look at it, the seconds down here forms a giant one with the seconds in this numerator. And then the minutes forms a giant one with these minutes. And then the hours forms a giant one with these hours. And then the days forms a giant one with the days. And the only thing I'm left with now here is weeks. So if I was to kind of collapse this and simplify it a little bit, at this point I have 1.5, and then this is all in the numerator, times 60 times 60 times 24 and times 7. And in my denominator, I just have all ones, right? I've got 1 second, 1 minute, 1 hour, 1 day, 1 week. So it's just all the number 1. And my units at this point are in ounces, OZ, per week. So I've gotten part of the way there, right? I've now gotten to a spot where I'm no longer dealing with ounces per second, but I'm dealing with ounces per week. What I need to do now is a similar thing with the liquid units, right? And I want to end up with gallons. So again, these are some giant ones that I provided you with. So as I look at these, I can see that I've got ounces in my numerator, so I want ounces in my denominator, OZ. And this giant one that I have, right, 8 ounces is the same as a cup. I'm just going to take the reciprocal of that. So I'm going to add here 8 ounces is the same thing as 1 cup. And I'm now going to multiply that by, see, I can get rid of the cups. So I'm going to flip this one also, right? Because I want cups to cancel next. So I'm going to put cups here and a quart, Q-U-A-R-T. So I know that 1 quart is the same thing as 4 cups. And then I think the final one that I need is gallons and quarts. So this time I'm going to be placing quarts in the denominator and a gallon in the numerator. And I know that 1 gallon is equivalent to 4 cups, 4 quarts rather. So as I take a look at this, I can see that my ounces will cancel. I can see that the cup will go away with the cup, and the quart goes away with the quart. And what I'm left with at this point is just gallons in my numerator and a week in my denominator. So I now am looking at gallons per week, although I don't know the number yet. So let me just bring this up a little bit more. And in the space provided, let me rewrite out this problem. So I've got a 1.5 times 60 times 60 times 24 times 7. And in my denominator, I have 1, of course, but then I've got times 8 times 4 times 4. So the units in my numerator are gallons, and in my denominator I have weeks. So it's still a rate, right? Gallons per week instead of ounces per second. So now let's take a look at what this number actually is. So I just start by entering the 1.5, and I'll just do times 60 squared, because that's 60 times 60, times 24, and then times the number 7. So my numerator here is 907,200. So 907,200. And the units in my denominator are 8 times 4 times 4, which is 128. So we are looking at 100, let me grab that, 907,200 divided by 128. And I get that is, well, they're going to need a bigger bucket if it keeps leaking like this, right? But if it was possible, right, it would be equivalent to 7,087 and a half gallons per week. That's a lot of gallons of Gatorade. In fact, I wonder if the team actually uses that much as an entire year. So anyways, again, the idea here is to just start with the unit, start with what we have, and multiply by giant ones, things that are equivalent to ones. And then the dimensional analysis is looking at our dimensions and seeing which things cancel out and which units we have for our final answer.